Good morning, guys. I wanted to jump on here real quick to kind of clarify the X and Y value coordinates and how their expression changes for translation, reflection, and rotation. All right. And so for translation, well, for all of them, we're always going to start with X comma Y. And the reason being is, even though we're in the second quadrant and the X values are negative, if we say this is a negative X comma Y, then we're saying that this value point is 3 comma 1, because once we substitute in this negative 3 for X, a negative negative will make it a positive. So we will always start with X comma Y because we're just saying that this is the coordinate point and you're just going to substitute the values in. So if you notice here, we start with negative 3 comma 1. This does not denote a negative or a positive. This just denotes that value. So once we're doing this expression, we're substituting it in, and then we're going to show the new expression after the transformation took place. So for this first one, it's purple dot, we're going to do a translation. So we notice that the X value here is at negative 3, but the X value here is at positive 3. So we just mark it and say positive 3. We notice the Y value here is at positive 1. The Y value here is at positive 2, right? And so in explanation for this expression, the X and the Y stay in the same positioning. They do not flip. They do not rotate. All they do is just move. And so we're going to keep your X here and your Y here. Now, what happens is we went 3 units, 6 units to the right. So let me widen this a little bit so we can have some room. So what took place was we have X plus 6 because X went 6 units to the right. And then we have Y plus 1. And the reason why I'm saying just a normal X plus 6 is because we just moved 6 units to the right. We're not talking about the actual value, because once you plug in negative 3 plus 6, you're going to get a positive 3. So this is why this has to stay as a normal X instead of a negative X. And then Y just moves 1 unit up, so we put plus 1, right? Now let's move on to reflection. So reflection for this, we're going to use Y equals 0 or the X-axis for our line of reflection. You notice that this is 2 units above and this is 2 units below. So reflects over the X-axis or Y equals 0. With that being the case, we notice that our X values do not change. So we can just put 3 here. We notice that our Y values do change. We have a positive 2 here and a negative 2 here. So when we're trying to figure out this expression, the X values stay the same, so we just put X. However, the Y values flip. And so we go from a positive 2 to a negative 2. So in this instance, we know it was a Y, a negative Y, because we did a vertical flip over the X-axis. Now, something that can be a little bit trickier is rotation. So let's go over rotation real quick. And so now what we did from this point, we rotated 90 degrees in a counterclockwise direction to here. And so we notice every time we do a rotation, the values flip. So I'm going to just go ahead and put a Y here, and I'm going to put an X here, right? We notice that our X value is now negative 1, and our Y value is now a negative 3, right? So our X value from the get-go was a negative number. So as this negative 3 flips, it goes to this negative 3, it stays the same. So we do not need to touch this X. However, our Y went from a positive 1 to a negative 1. So now we have to say negative Y. So if I was to do a rotation with another point in this quadrant, and let's say I go from negative 2, 2 and I rotate it to -2, -2, our y value is the only thing that's changing, because as we're rotating, our x values started off negative, they finished negative. So we just put x. Our y value started off positive, they finished negative, so that's why we put a -y. Again, hopefully this clears up some of the things we went over in class the other day. And if you guys have any questions, please do not hesitate to email me.